A ball of mass 200 gram moving with a speed of 20 meter per second hits a vertical wall at an angle of 30 degree with the wall. That means that angle made by the direction of velocity of the ball is 30 degree with the wall. And so this is important. Where do you indicate the angle? 30 degree is important. And it rebounds back with the same speed at the same angle. Ball was in contact with the wall for 0.1 seconds. Find the magnitude of force exerted by the ball on the wall. Okay. So you'll have a small diagram to explain the whole problem. The wall is vertical like this, and the ball is moving like this. It is hitting the wall and rebounding back with the same speed and at the same angle. So if I draw a normal here, they describe this angle as 30 degrees. This is 30. Then this angle will be 60. Of course, you can take any angle to take the components. Mass of the ball is 200 gram, which I can convert into SI unit as 0.2 kg. 200 gram is equal to 200 into 10 to the power minus 3 kg. So 0.2 kg. And while returning, the mass is same, 0.2 kg. The speed is same, so it is returning with the speed of 20 meter per second while returning back. And here also it is 20 meter per second. There is no change in the speed, there is only change in the direction. Now, if you want to know what is the magnitude of the force, F equal to ma, that is the formula. And if you want to find out acceleration, you have to find out the change in velocity. Final velocity minus initial velocity divided by time. Now, the change in velocity here has occurred only because of direction, not because of magnitude. Magnitude of the velocity is remaining the same. Only the direction is changing. It was 20 meter per second after hitting. Even before hitting, it was 20 meter per second. So how to find out the change in velocity because of only direction? Take the component of this 20 meter per second along the wall and perpendicular to the wall in two directions. So along the wall, the component of this, I will take this 60 degree as the angle. Then wherever you don't have the angle, you will have, you have to write here, it is sine 60. So here it is, in this direction, the velocity is 20 sine 60, a sine theta. That is the other component, 20 sine 60. And if you take the component of the same 20 meter per second here, it will be like this. It is in this direction. See the direction of the motion of the ball. It is like this. So in this direction. So here I have to mark it like this. This is 20 cos 60. 20 cos 60. Now, what about after hitting the ball and going out of the ball? Then the direction will be different. So if you want to mention the components here, see the direction of the ball, it is like this. So now if you take a component in this direction, and again take the angle, this one as 60, then this is the 20 sine 60 along direction which is parallel to the wall, and 20 cos 60 here, it is in this direction. So you see the direction of motion of the ball. Then the component here along this direction will be like this, 20 cos 60. So 20 cos 60, since 60 is here, it is cos 60 here and sine 60 here. So component of this velocity while hitting the wall is the 20 sine 60 here, 20 cos 60 here. While moving away from the wall, 20 cos 60 here and 20 sine 60 here. Now, if you separately look into the change in velocity in the two directions, that is x and y directions. Along the wall, the direction hasn't changed. Direction remains the same and magnitude also remains the same. So along the wall, there is no change here. No change along the wall. No change in velocity along the wall. And of course, the direction was also downwards in both the cases. Direction is downwards. Whereas along the x-axis that is perpendicular to the wall, there is a change. There is a change of velocity along this direction. So it was 20 cos 60 and it was going towards the wall, and it was 20 cos 60 only, but coming away from the wall. So change in velocity is only in a direction perpendicular to the wall, which is equal to, so final velocity, if I take it as 20 cos 60 in this direction, then the initial velocity is like this, which has to be taken as, and change has to be written. Change means the difference. So 20 cos 60 minus another velocity is minus 20 cos 60, because it is opposite to the initial direction. So it was moving like this along a direction perpendicular to the wall, but it comes back again perpendicular to the wall in the opposite direction. So I have to put one more negative, because I want to find out V minus V naught along with a sign. So V is, if it is taken positive, then this minus V naught is opposite. So minus 20 cos 60. So if I substitute for this formula, what will be the answer? F equal to mass of the ball 0.2 kg, that is 200 gram, into acceleration. Acceleration is change in velocity by time. So this is 20 cos 60 minus of minus 20 cos 60, that is plus 20 cos 60, divided by time is 0.1 second. And they have given it that the ball is in contact with the wall and the exchange of forces takes place for 0.1 seconds. So what is the magnitude of force exerted on the wall by the ball is 0.2 into, and this will be 20 cos 60 is 20 into half. Cos 60 is half. So this is 10. 10 plus 10. So 20 divided by 0.1, and 0.1 2 times 0.2. So that comes to 40 Newton. That is the answer. Thank you.